Hi, everybody. Welcome to our power focused webinar for Square Robot. We'll give it a few minutes to let everyone join, and then we'll kick it off, maybe like a minute. But while we're waiting, good morning to wherever you are. I hope you have your cup of coffee or your cup of tea. I'm here in our Houston office, which is where, if you can see behind me, we have, you can't see too much, but we have our service center. We also have a storage tank that's behind me outside of this conference room where you might see people passing back and forth because we are about to do a robot launch this morning. So that might happen. But a little bit of background, and then we'll kick this off. My name is Stephanie Nolan. If I haven't had the chance to meet with you or speak with you, I'd love to set up time after this webinar. I've been with Square Robot for a few years now, and the entire time I've been focused on the power generation industry. So any of the tanks that we've done at power plants, I've seen it all, which is why this webinar is great, because I've filtered all the questions. I've seen anything that will come up. And that's really what we're going to talk about, really specific to power plants. So let's go ahead and kick this off then. Okay, so if you have no background on Square Robot at all, we are a submersible robotic tank inspection company. So at power plants, we're thinking your above ground storage tanks like this in that top left picture. Usually what we see at power plants, it's going to either be your water tanks, all kinds of water, processed water, condensate, demineralized water, fire water. We see all the water, as well as fuel oil. And at power plants, that's either going to be maybe your red dye diesel. We've even seen jet fuel at power plants. Every once in a while, we'll come across a lube oil tank, which is also something we can inspect. But I do get a lot of questions about horizontal bullet tanks. So instead of this above ground storage tank, it's going to be either horizontal or even vertical, but one that sits in the saddle. I'll address that a little bit later. So let's keep going. The tank inspection world, if you've ever done tank inspections at your power plant, or if you have one coming up that you're unfamiliar with, typically how it's been done for your inspection, your API 653 or NFPA inspection, is that you'd go ahead, drain the tank, vent it while it's draining if it had fuel oil in it, clean it, dispose of that waste, and then send people inside of the tank. They'd run an MFL, which is basically a screening tool detecting if there might be corrosion, but not actually measuring corrosion. Then they'd come back with a spot UT to actually measure that corrosion, potentially provide repairs if it's out of service, if it's needed, or even if it's not needed since it's already out of service. Now, with this, I don't know about you guys, but I'm in Houston. I think it's important that we don't have people crawling inside of tanks. And I tell you what, I don't want to be inside of a hot tank in the middle of August in Houston. So with this, what we look to do instead, hold on. There we go. What we look to do instead is use a submersible robot. So taking the place of human intervention, we drop in our robots instead so that we can get that full corrosion reading. And we're looking to provide a few things. First, on that HSE side, we don't want people in confined space. We don't want to release those emissions. If there is another alternative, we want to provide it to you. And I say this with the caveat of not every tank is a robotic inspection candidate, and we'll touch on what that means and what candidates do look like. But when you have the option to use a robot instead of putting humans in those environments, it's really imperative to just at least look at the option. We also keep the tank online. So your tank is operating during this. You don't have to take it offline. We ask for lockout, tagout, but that's not always the case. Sometimes it's static or flowing. Don't have to bring in backup storage. I've seen a lot of power plants that have just one fuel oil tank, and to take it offline, they'd have to bring in frac tanks or either truck the fuel out. And then we want to do this while providing you even better data than you've gotten in the past. So what our sensor package does is that we're providing between 2 to 4 UT data points per millimeter. So super high density, super high quantity. And you think it's not just screening, it's actually calculating that wall loss while we're inspecting. A little bit about us. You can see this right here. We are a global company. We've worked all over the world. But I do want to point out this is our impact overall. Power plant specific, we've done over 75 tank inspections that I've been a part of. So when I said I've seen it all, I have. And I want to point out this product chart on the right. Water and diesel is the majority of what we've done because that is what our first generation robotic fleet was designed for. Our newer fleet is designed for more volatile products. So you think really viscous products, lube oils, gasolines, really volatile products, things that we might see more in midstream or downstream. But we now have the capabilities to touch it all. And with water and diesel being the majority of what we've seen, we can answer any questions you might have. All right, tea break. Moving on. What we're going to provide at Square Robot is the complete full package, your API 653 inspection. So if you do have your API 650 tanks that are coming due, and I want to say this, knowing that tank inspections aren't frequent, you'll probably see, if you even know when your tank inspection is due next, it's not frequent. It's probably somewhere between 5, 10, 15, 20 years in between each inspection, which is why it's nice to have the option of robotics to use, because a lot of times some of that knowledge transfer on how it was done in the past doesn't get actually transferred to maybe a new person who stepped into that role. But what we're going to do is provide the different components for your API 653. And with the robot itself, we're thinking of anything inside of the tank that you can't see without somebody going in. So we'll do your tank bottom thickness readings using our phased array ultrasonic. We're going to have internal visuals. We have 2 cameras, one that looks directly down at the phased array UT and one that looks outward. We'll also provide your tank bottom settlement report. And then if you do have your externals due, our crew does come with a crew of 3. So if you do need externals, we'll send out that API inspector, your robotic engineer, and your field tech so that they can provide manual externals on everything you can see. So shell, roof, nozzles, all of that, we can provide external manual UTs. If your company is big on robotics, I'd love to hear it, love to see it. We can, instead of manual UTs, if you want no human intervention, we can get a small shell crawler instead. All right, my PowerPoint's being just a little slow. There we go. So biggest component of the robot and most important is going to be your phased array ultrasonic panel. You can see it in this video. What we do is we design the robot to push right against the tank shell. So we're within ½ inch of that tank shell, which gives us full access to the critical zone. And that's where the shell meets the tank floor. So that area that's most susceptible to outside environments. We want to focus on that critical zone and then get readings throughout the inside of the tank. I said it earlier, 2 to 4 UT readings per millimeter. With that, you can see this scan at the bottom right. We're able to delineate between, when we do the measurements, actual soil side or top side indications or wall loss indications. So soil side, whatever your tank is sitting on, it could be sand, cement, versus top side where the product would sit, water, fuel oil. We're able to delineate and measure those in your final report, which is reviewed by your NDT, our NDT level 3s and API inspector. We will notate if any are above your API threshold that will affect your API inspection interval. Now, the settlement survey that we do, this is actually my favorite part because tanks and robots are my life now. But the settlement survey is how your tank is slowly sinking over time. So either sinking into that foundation or if you have concerns about tank shell buckling, but it's basically, it's not going to stay rigid. The tank has a little bit of flex with it. I call it the lung. So we do this while the tank is full. So you don't see that flexion when you empty the tank. We do this fully loaded. And how we do this is as the robot goes down and traverses the tank bottom while it's actually scanning with the phased array UT, we have a sensor package that's measuring the fluid column that sits above the robot. So we can understand if you do have low spots, if you have depressions, we can measure those, build out that real-time map. You can see this right here. Water puddling that was sitting underneath their fuel oil. They couldn't access that even though they had done a water drawdown. They still had those low spots. So what we want to do is give you that full look into your tank integrity, not just high level. We want to be able to provide the readings, the settlement, as well as those visuals. You can see right here that camera looking down at the phase array UT. All right, moving on. So I did want to touch on this a little bit because I get asked about NFPA, fire suppression, or fire water tanks all the time. And this is really, it gets a little gray, and it's really site by site and company by company. What we do at Square Robot is provide anything that could be questioned. So in the NFPA code, you can see right here, 9.264. So exhibiting signs of interior pitting, corrosion, failure coating, that's going to be visuals. First of all, we go into a lot of tanks where they just want visuals for these fire water tanks. We can provide that. But what we want to do instead, because you can see down here, test during interior inspection, non-destructive ultrasonic readings will be taken if there's evidence. What we want to do is just jump over that before that question even comes up. So what we look to do is provide really what we're doing for your API 653. We would just do it in a distributed manner. So it's not going to take as long. It will be a little more cost efficient. We'll focus on that critical zone and then get distributed PAUT coverage. So I call it like the chocolate chip cookie. And this changes depending on your tank, how many columns it has, all of that. But we'll focus on that critical zone and then get a nice distributed coverage of UT readings so that we can at minimum build a corrosion rate, but also give you an idea of what your tank is looking like. Do you have issues? You have the visuals, you have UT readings so that you're fully covered. I see this mostly, people will send this to me and they'll ask like, oh, well, we have to meet our insurance requirement. So I did want to touch on that because it comes up at least a few times a week. Now I'll get into a little bit of our new technology. This was a need that actually arose from the power industry. They had one of my clients had a really large insulated water storage tank. And when I say large, it's the biggest tank I've ever seen, 90 feet tall. They were worried about corrosion under the insulation. So what we did is we worked with our R&D team here, and we took the phase array UT from the bottom of the robot, reoriented it. You can see that bottom picture so that it sits on the outside so we can push it up against the tank shell. We can get UT readings on that tank shell, and then we can give you a better idea than just maybe a UT, manual UT in your porthole, if you even have portholes drilled, but a better idea of what that tank shell and what those conditions look like. We've been working on that for probably about the past year. We are at the point now where we can go ahead and actually identify where it sits in the shell, what those readings look like. Anything that you'd see on the tank bottom, we now do for the shell as well. Okay, I'll get into a little bit of the ops. I wanted to start high level just in case you had no idea what Square Robot was or did, but I'll get into our mobilization. I'll hit some frequently asked questions, the things that I see all the time. The first is going to be, how do we get the robot in the tank? So there's two ways you can look at this. One is going to be, the question is, do you have a site crane? Some plants do, some plants don't. If you have a site crane, we pick it from the crane. We'll go ahead and drop it through your roof manway, which we do require a 24-inch roof manway. We'll drop it. It will complete its inspection. It says autonomous. If I have my engineering team on the line, they're going to love it when I say this. But I like to say, think of it like a Roomba that's already learned the layout of your house. We're going to put in your tank drawings, your past inspection reports, build a mission plan so that we can complete that inspection. But sometimes these tanks are super old, built in the 70s, something's been added or taken out. You have a new pipe, a ladder got removed, who knows? In that case, we do have the robotic engineer who can take control. So semi-autonomous. Recover, decontaminate, and then on the back end, we have a 2-week report turnaround time where we go through all the data. And when you think about that 2 to 4 UT readings per millimeter, it's a massive file, more than my phone holds, almost a terabyte of data that we're sometimes going through. Now, the other option, if you don't have a site crane, is our incline lift system. You can see it right here. What we do instead is we'll, put the robot in this cradle. It rolls to the top of the tank. There are a few considerations here when we look at this, but it's a nice alternative so you don't have to get another third party. Considerations, we want to make sure there's not a handrail sitting all the way around the tank because we do roll the robot off. We also want to make sure there's not a super steep slope on the roof because we have our guys there, and you can see right here what we'll do is set up a manual hand crank crane to lower and lift the robot. Lastly, because this came up yesterday actually, is that we do need a flat surface for our incline lift. So 3 things to think about, but it's a nice option if you don't have a site crane, that this might be, a potential avenue that you can go instead. Okay. So let's get to your outages. And I say this because March is right. I'm going to blink. It won't be March. It's right around the corner. Most plants that I talk to are kicking off their outages sometime in March, maybe April. But I get a lot of requests to, one, either do their inspection during the outage, or can we do it outside of the outage? So there's 2 schools of thought here. One, you have your outage season. You're already going to have a ton of contractors on site. Maybe you already have a crane on site. It makes sense. But what we want to emphasize is that these tank inspections can be done anytime during the year. So if you have major projects going on during your outage season, I like to say focus on those. We can do them a month later. We can use our incline lift. We're very self-contained. And I want to touch on how we can do this. So what environments can we conduct our tank inspection? I hit this earlier, but we ask for lockout tagout. That's like our standard minimum static. But if you need your tank flowing, we can inspect in flowing tanks, and we've done it multiple times. What we'll do ahead of time is run a flow analysis through our engineering team. We look at the inlet, the outlet, we take the sizes, the flow rates, and make sure it's not a super turbulent area that's going to push our robot around. If it is, we just work with the site. We've done a few actually water tanks that were used both process water and fire water where they needed a flowing. All we did for that inspection was lower the flow rate for that day. We didn't completely shut it off. We just lowered it for that time that we were in the tank. They kicked it back up once we were out. So wanted to hit that first. The other one is going to be, what if I need my tank while the robot's inspecting? These questions all came up seriously yesterday for me. I hear you, especially those fire water tanks. In the event that happens, the robot is connected by it's a 1/4-inch fiber optic tether. With that, as part of our redundancy for safety, it is, I call it fishable. So once the robot is in the product, water, fuel oil, whatever it is, it's only 10 pounds in the product. So you can quickly fish that robot to the top, let it hang, and use your tank while our robot's there. We would just let it hang until it's done, and then either retrieve the robot or finish the inspection. And then the last thing, because this comes up, what if there's a weather event? Hear ya, it happens all the time. There are a few things that we want to look at. One is going to be high winds, especially if you're using a crane. We've run into that scenario. That can delay a job, not necessarily cancel a job. We can always push it a day. But the other one's going to be thunderstorms, because that happens everywhere. And I wanted to point out that once the robot is in the tank, everyone is off of the tank. Our guys are either, you can see the box truck or a mobile van. Guys are sitting there, so we don't have to worry about the weather. We have about a 30-ish minute period at the beginning and the end of the day where we're picking the robot, dropping the robot. So it's really those time frames that we have to watch the weather. So hitting all those questions that I get asked at least every day, every other day. If you have more, I'm happy to answer them. Like I said, I've seen pretty much everything at this point. But I'm going to wrap up with a case study and then a little bit of what we would need to move forward. So case study, this was actually last year. We did a CCGT plant out in New York. They had 5 tanks. It was going to be 4 water tanks, 1 fuel oil tank. We inspected all 5 in 5 days. So when you think about your timeline, I've talked to plant managers in the past where they had to truck fuel out. It was going to be a month of out of service time. 5 tanks, 5 days. And a good rule of thumb there, don't hold me to it, but a good rule of thumb there is about a 60-foot diameter tank and below, we can inspect in about a day. Now, if you have tons of columns or anything like that, maybe a day and a half, or if the tank is really large, It doesn't correlate that 60 feet and then 120 feet equals 2 days. No, usually the bigger the tank, the longer it takes. But 5 tanks, 5 days, we save them over 1,000 pounds of CO2 equivalent emissions. And most importantly, for me right now, confined space entry hours. Over 1,000 confined space entry hours eliminated. Now, I say most importantly for me because you're probably like, well, what about cost and savings? So this plant was able to do, because they did have a lot of water tanks, usually we'll do that distributed coverage. We did all 5 under 125,000, savings for them over 200,000, win-win across the board. Wrapping this up, and then I'll move into questions. I like to hit, I know I mentioned this earlier, tank candidacy. So what does it look like? We touched on the fact that what we've worked in at power plants, usually your fuel oil, your water, sometimes lube oil. It's not on here, but I did want to circle back to the word circle back. We're in 2025 to those bullet tanks. So either horizontal or vertical. Those wouldn't be an API 653 inspection, and those actually wouldn't be a fit for the robot. But what we can do is if our crew is coming out for that inspection, it would probably be an STI inspection. We can have one of our certified inspectors do the externals with manual UTs at the same time as we do your robotic inspection. Now, you have to check your site-specific plans. Sometimes those things have to be emptied. So we leave that to you, or at least to send us the information to help you decipher. So looking at tanks that you might have, what would we want? We would send out our tank questionnaire. So we want the tank and site information that helps us plan, but we definitely need tank drawings, past inspection reports, SDS. I'd say that's usually for maybe other industries. It's typically water and diesel that we're in. And then the considerations. So what tanks are fit for us? I already touched on those bullet tanks. We want to work in those large above ground storage tanks. So we have to think sediment level. I've seen some water tanks pulling straight from the Mississippi. On the bottom, they had like 8 inches of Mississippi mud. And I'm from Louisiana. That stuff is thick. That is not something that we can work in. I'd say about 3-ish inches of sediment is what we can handle, because on the front side of our phased array UT, we do have a sediment removal system. But think brush, not vacuum. We're not going in to clean your tank. We're just sweeping away sediment so we get good scans. We also want to look at internal appurtenances, so columns, nozzles, anything like that. Typically power plant tanks, I don't see anything too crazy, anything that we've run into that we couldn't inspect in terms of appurtenances. We usually see some of the crazier tanks in other industries. We also ask for a 24-inch roof manway so that we can launch the robot. If you do have a tank that maybe has a 20, it's older, or 18-inch manway, we have worked with other companies who have cold cut in a larger manway. Depending on the tank and the location, usually for fuel oil, it makes sense. It might still be more economical for you to actually install the manway than take it out of service. So I can give you more information if that's something that you have at your site. But then lastly, we do ask for 15 foot of product in the tank. And that's because our robots are all C1, D2. And part of our safety certification is the robot doesn't even turn on until we have 10 foot of product above it. Same thing on the way up. So when you think it's dropping down, we hit the 10 foot, that gives us at least 5 feet to really swim around where we can get good visuals. Don't drain your tank down to 15 feet. People have asked that. The more full, the better. It gives us more space to swim, more space for visuals. So if your tank is full, keep it full. I'll move on to some questions. That wraps up everything. Very high level for power plants. I'd say every time I go out for a job, it's really nice because I get to talk with the plant manager and the site personnel, and they always say it was way easier than they anticipated, because we come in, we have all of our safety certifications, we've done your site training, and then outside of that, the tanks usually are kind of in their own little space. We go to the tank, we drop our robot in. Once the robot's in, inspection is underway, really self-contained. And we like to call ourselves the easy button for tank inspections. You don't have multiple vendors. Especially if you're using our incline lift, you don't have to worry about any of that, or people in the middle of the plant because tanks usually aren't like right in the middle. But even if they are, we're pretty much set in our mobile operations van. So that wraps it up. I'm checking the comments. I don't see too many, but if you do have a question, drop it there. If not, I see they posted my info. Yes. So if you want more information, it's snolan@squarerobot.com. Reach out to me. And then I think that's it, you guys. Happy Wednesday. Happy to send this presentation out to you if you'd like it. I can also send our product compatibility sheet and a tank candidacy list. But I have meetings with power plants every single day. So if you're curious, if you have a tank inspection that's coming up either this year or next year, we can definitely look at pricing for it. Okay. Hey, Cliff. So I'm going to take that first question. Sediment. What is the acceptable percentage for issuing reports on the equipment's remaining useful life? That's a great question. So API standard, the API 653 code doesn't actually put a percentage on how much of the tank bottom you need to inspect, which is crazy. It's usually up to that site, but I will say we've been in a few scenarios. One, where we went in and the past inspection report, they'd only gotten readings on one tank plate. That's wild. We want to get as much of that tank bottom as we can get. So we'll look at the tank ahead of time, look at the columns, look at everything's in there, understand if you're worried about sediment, anything like that. What we can do on the backside, if you feel like we haven't hit enough areas, is we'll pair it with an extreme value analysis. And what that is just that statistical analysis that really bolsters your confidence level on what the tank looks like on the bottom. So we pair those together. We've done a few of those in the power industry. Some people request them, especially if they don't want us out there for a week. Maybe it's a bigger tank. They say 3 days, but let's pair it with the EVA. Now, industry standard, and I'm still on Louise's question, industry standard outside of power kind of varies. People say, well, we want at least half of the tank inspected. If not, we'll pair with the EVA. It varies on what they want and customer to customer, but we have a good idea before heading into the tank, as long as we have good drawings on what that will look like. Like I said, for power plants, we don't see a ton of crazy scenarios. We usually hit all of that tank bottom outside of the columns because you can't lift those up and get underneath them. Any other questions? Thanks, Anthony, for joining. That was a great question. Okay. I'll give it one more minute in case someone's typing. I'll have a sip of my tea. I'm a tea girl. I don't know if they started doing any robotic launches while I was behind because I had the PowerPoint up. But if you are in Houston, if you ever want to do a robotic demo or a site visit to our service center here, happy to bring you in. We have behind me our storage tank. We also do a ton of customer demos where we'll drop the robot in. We'll walk you through the robot because we have them here, each of the components, answer any questions. You can bring in your site personnel. So that happens frequently. Just reach out. I'm always here in Houston. Okay, I'd say that pretty much wraps it up. Thanks, Louise. Thanks, everybody, for joining. I'm going to go ahead and end this. Please reach out if you'd like a copy of this presentation. Or if you have any additional questions or a tank that is coming due for inspection. And we will talk soon. Bye.